just for completeness, I want to follow up on yesterday's video to Brian and show what a position fix actually looks like when you use the AE map. But first, we're going to reiterate the main point of yesterday's video, and that is the circles that Brian produced using that website do not appear as circles on the AE map, but they are circles on the globe. So here's the first GP, which is 40.1 south, 78.3 west, and its radius is 4,450 kilometers. On the left is the azimuthal projection that Brian made with that website. And as I pointed out in the video yesterday, the only map on which this is actually a circle is the globe. It is not a circle on the AE map.
Ruhif, if you would ever understand and learn how the AE map works, you wouldn't be saying this horse shit. You're basically saying on the AE map on the left, it is a circle of equal altitude, but when I project it to the AE map on the right, centered around the North Pole, it isn't. You're stuck around the North Pole, bro. Now pay attention, because I'm going to show you how circles not lined up centered on the globe are also not circles.
And just for shits and giggles, if you took that circle you drew on an AE map and then projected it onto a globe, then it looks like this weird teardrop shape. Again,
now I want to point out the misuse of the AE map by people like Bob the Science Guy and Ruhif. They try to use Euclidean geometry when latitude-longitudes are mapped from the equator, 90 degrees to the North Pole, 90 degrees to the South Pole. They want to try and make an entire circle out of the 180 degrees and use Euclidean triangles. That's not the way the map is made. But since we're going to do that, and since they absolutely do that and strawman the AE model, let's see what happens if we try that on a globe. Because the AE map, like the AE map generator, is egocentric. Means wherever you're at, that's the center, and that's where you do your math from. But if we do that from the globe, we take Ruhif's exact measurements to the North Pole, his exact coordinates, and we go to the North Pole, then to the other coordinate, and then we connect it to. And let's scale these distances. Do these distances scale, Ruhif? And how about these azimuths? Are they correct? No, I don't think so. And this is what you get from Google Earth. Anywhere from the North Pole, if you're not lined up with it. That's what you get. So if we use, let's apply that to the globe. If we take equidistant lines, let's say the Arctic Circle is the circle of equal altitude. And let's draw some lines from the North Pole. They are all, if we center over the North Pole, they're correct. They all make it out to the Arctic Circle. But if we misalign it, and the North Pole is no longer in the center, like what you did with the AE map, then look at these equidistant lines. They're all over the place. So your strawmanning of the AE map is pretty weak, man, because we could apply the same or similar problems to the globe. So I ask y'all, quit strawmanning the AE map. Use it how it was designed, and that is egocentric. So by holding the North Pole hostage, making that your measurement point, then nothing is azimuthally equidistant to anything but the North Pole. When on the AE map, any spot is, you're going to have azimuthal equidistant directions to anything else. Wherever you put the sun, planets, or locations on that map, you've got azimuthal equidistant lines to everywhere else. But you've got to do your measurements from your position. I repeat, from your position, just like on the globe there. So you see, on the globe, if I'm not centered, my distances are not scalable. I just showed you the distances are not scalable if you're not doing them from the center point.
in Brian's contrived example, he deliberately set the GP of the third star to be 40 degrees of longitude away from Quito, thinking that it's 60 nautical miles per degree of longitude on the equator. Now, that is true in reality, but not on the AE map. On the AE map, the length of the equator is the circumference of a circle, that is 90 degrees of latitude from the pole. So it's 2 times pi times 5,400 nautical miles, which is almost 34,000 nautical miles in circumference.
Rohit, you obviously haven't looked closely to Gleason's instructions. If you had, you'd know that the AE map, the degrees of longitude, reduces to the sun time in minutes. That's minutes of arc, which equates to, as seen on screen, 60 nautical miles per degree. So if you are using the AE map and you are not getting 60 nautical miles per degree, you are not using the AE map correctly, Rohit. So when using latitude and longitude, you are measuring to the celestial sphere. There's no other way. It's to the celestial sphere. So you're not going to use Euclidean geometry. You're going to use the Haber-Sign formula or something similar. This is how you map a celestial sphere onto a plane, and you use the Haber-Sign formula from wherever you are located on that plane. You don't pin yourself to the North Pole and try and use measurements from everywhere on that map starting at the North Pole. It's not how it works, Riv. Now if we look up the Haber-Sign, it says the Haber-Sign formula determines the great circle distance between 2 points on a sphere given their longitude and latitudes, important in navigation. Now what they don't always tell you is that Haber-Sign means half sign. Half meaning it never applies to more than a hemisphere. The math only works from the center point on a plane projected up to a hemisphere. Another thing they don't always tell you is that the Haber-Sign is worthless without a radius equidistant to every point on that hemisphere. So from your center point on a plane to every point on that hemisphere is the radius. Without that, you cannot do the calculations. So when you think you're on a globe and you measure 3 elevation angles, then that's the point where you chop your globe in half, put yourself in the center of it, and do your math up to that hemisphere. Same thing as being on a plane and projecting up to a celestial hemisphere. So if you are using latitude and longitude, your straight line distances are great circles in which you have to use Haber-Sign. But once again, that math only works from the center point on a plane projected up to a hemisphere. That's the only place and way it works. That's how the math is described in the Haber-Sign formula. From the center point on a plane. So if you're using the AE map, then you center yourself on that plane. So if you are using the Haber-Sign formula, it doesn't mean that you are on a sphere. It means that you are doing the math projected up to a sphere or hemisphere. The Haber-Sign formula does not work from the surface of a sphere projected up to the surface of a sphere or hemisphere. It only works from the center of a plane projected up to a hemisphere. The math doesn't work from the surface of a sphere to a celestial sphere. They can't both be spheres. And if you want to help support me in my up and coming projects, there are 2 ways to do so on screen. And once again, thank you for watching.